Good morning, everyone. Good afternoon now, I suppose. So my research project this year, I was busy doing my honours, and what I've done is the conservation implications of microplastic fibres uptake in the caridean shrimp Palaemon peringueyi. So Palaemon peringueyi is this beautiful little animal that's caused me headaches this year. It's commonly known as the glass or the ghost shrimp. So my colleagues have touched on many of the points that are in my presentation, so I'll just touch on them again, but mainly gloss over them. So the species is an omnivorous scavenger. As you can see from this first image over here, they're even willing to feed on their own kind. They play a vital role in keeping down the quantities of dead tissue, both vegetative and animal. They have quite a widespread range. So this range is often debated. So some say it doesn't get out of the Eastern Cape, which I know not to be true because I collected them in Durban Harbour. And there's other papers that say they go all the way up to Richards Bay. So this was taken from two oceans in 2008, and that showed the extent of their range around southern Africa. So it definitely does extend further. And I know I believe her name was Mary, did a speech yesterday, and she said they found very high quantities up near Richards Bay Harbour. So it definitely extends up the north coast as well. They are a vital food source for a number of animals. So in the bottom here, I'm a fishman at heart, so it's more my interest, but this little guy over here is a half-moon rockcod, Epinephrus rivulatus. This is a juvenile. He's probably about 10 centimeters long, and at that stage in their lifespan, these shrimp are generally between 3 and 5 centimeters long as an average size, I would say. So they make up a large proportion of the food sources of these species. Back to the range, they are found from depths of less than 1 meter, and they've been recorded all the way down to 45 meters. Especially in your estuarine habitats and also nearshore habitats are where they're predominantly found. So microplastics, what they are, how they're defined has already been covered. They're less than 5 mils in size. So what we used for this study was a fluorescent safety jacket because it's made of 100% polyester, and the fluorescent allows us to view it under UV light. So, of course, these polyester materials, as I said, go through washing machines, get into the wastewater. The treatment plants can't handle them. From there, they enter the rivers and ultimately into the marine environment. The aims of the study were to determine whether microfibers were actually taken up by the species. So, as far as I'm aware, none of this research has ever been conducted on the species before. I couldn't find any literature dealing with microfiber uptake in Palaemon peringueyi. The second aim was to determine if increased microfiber concentration resulted in a greater uptake. So, Selton-Rich 2015 found, as has been pre-mentioned in some of the other speeches, that microfibers can take up these toxins. So what we wanted to see is if these were taken up, there's a potential for bioaccumulation in other species, etc. So essentially determining whether these fibers are actually taken up by the species is critical. As Gemma mentioned in her speech as well, they can slow the rates of the feeding process in a number of invertebrates. So this was also reviewed by Wright et al. In 2013. So preliminary experiments, a number of preliminary experiments were conducted for this study just to ensure that we didn't have confounding factors affecting the results. The first thing was to scan all of our equipment, all the food, the water, etc., all the materials used for any contamination of fluorescent items. So that whether this was plastic or anything else, we wanted to ensure there was no fluorescent contamination. Then onto the validation experiments. The first one is a 48-hour depuration. So for those who don't know what depuration is, it's basically allowing the animals to clear out their guts and ensure that there's no contamination within the animals. This was run before every other experiments are conducted as well to ensure there was no contamination. Food stability was important, so what I was doing is testing a new method of making flaked food, a commercially available flaked food, which I'll go on to for a little bit later, and basically seeing how stable I could make these mixtures to ensure that I wasn't getting a lot of wastage from these animals. Wastage and ingestion, so basically determining how messy a feeder these animals were, so I could actually ensure that the uptake was genuine uptake and not just by chance. And then finally, to make sure there was no adherence to the carapace of the animals, so microfibers carry a static charge, and what we wanted to ensure was that this wasn't sticking to the outside of their carapace as they were feeding, and then they weren't actually ingesting as much as they could have. And then, of course, that they weren't ingesting via filtration. So they're known to be mechanical feeders, and we just wanted to ensure that this was definitely the case. So the main experiment was obviously a presence-absence experiment to first and foremost determine whether or not they're actually taking these up. So Noel and Fronman in 2015 did a research study on the southeastern Cape, and they found fibres in the sediment of between 600 to 3,000 per square metre. So this is quite a varying range within the range of the shrimp. So what I did was I used 3 different concentrations. The 0% was a control, just to eliminate confounding factors. So if there were any in the control, I'd subtract them from the other 2. And then the 5% and 10% were of the total weight of the food mass. So the first hypothesis, will microfibers be present in the guts of all feeding shrimp? And then secondly, to quantify if ingested microfibers had a significant effect in the difference between concentrations. So of course with this study, we had to take into account ethical considerations, as they are live animals, and a higher invertebrate. So we had to get clearance for that. And then we took euthanasia. I approached Ushaka Marine World. I've been fortunate, I've been volunteer there for a number of years. I approached them and gave them an SOP and determined that the best way to euthanize these animals without actually damaging them was to put them in a freezer for a period of time in some small amounts of water. So basically what happens is it slows their rate down to essentially they go to sleep. So the methodology, the fibre production, which was touched on in Gan's speech, took a fluorescent safety jacket, cut it up very fine, suspended it in ethanol. So what the ethanol does is actually allows the fibres to separate. So when you put them in a vial, they tend to clump together quite a lot. So after they've been separated in the ethanol, filtered them through a number of different fibre sizes till I got the size class I wanted. I was working between 50 and 125 microns just to ensure that it was within the range of the shrimp's feeding. And then this was dried and then stored in a glass vial. Fibre incorporated food, so I used omega-1 flakes. This is just a commercially available marine flake food. The shrimp are known to take up most of your flake foods. Added a little bit of distilled water and the required amounts of fibres, mixed this all together into a homogeneous paste, dried it, and then re-flaked it out, basically. The analysis, so the presence absence, we didn't do any statistics on. It was purely to determine whether there was presence or absence in the species. And then the quantification, we ran one sample Kolmogorov-Smirnov test. This was just to ensure that the data was normally distributed. The significance was tested with an independent samples t-test. So the results of the initial experiments. For the depuration experiment, every time we ran it, 100% success. No mortalities there at all. There was no carapace adhesion from the shrimp, which was a great sign to see. So we found, especially with the mussels and stuff, that there tend to be adhesion to the shell, but these guys seem to have no adhesion, which was fantastic. There was no ingestion via filtration either, and low fibre concentrations had a better stability when I tested the flake stability. They were quite messy feeders though. 35.21% of the food remained uneaten, but I actually had quite a few issues with this. This is what gave me most of my headache, is the first few times as we were having issues with the quantity to feed them. I eventually found a paper which said they generally feed between 0.1 and 0.7 grams. So you're feeding them exceptionally small amounts of food, and this is what I eventually managed to get down. So for the first ingestion test, 80% success rate. So 80% of these animals actually took up fibres, but then what should be noted is that during the final test, so the 5% and 10% concentrations, we had 100% uptake. So for whatever reason, 2 animals in the initial experiment just didn't eat. 5% and 10%, you can see the 2 averages there of the fibre counts per individual. 513.75 as opposed to 2,880, and that's between a small concentration change. So one of my favourite parts of this experiment, and I secretly had this as a thing that I wanted to see before the end of it, is that I made a shrimp glow. So this was actually one of the shrimps from the 10% experiment, and you can see there in the gut the glowing mass of fibres that he had taken up. One of the advantages of working with a transparent animal. So we did have significant uptake between the 10% and 5% ranges of 0.015, which is less than a cutoff value of 0.05. So why is this study significant? The main reason we did it. Uptake in Palaemon peringueyi has never been studied. So this is an initial study. We never knew anything about them and their microplastic uptake before. So it now allows an avenue to further research them and determine whether they're actually taking up plastics from the wild, etc. Habitats and location, very important species in the estuarine habitat. And that leads on to the ecological role as well. So Fronman and Henninger 2010 found that this species was actually very important, especially in the Eastern Cape estuaries, in transporting nutrients from one point to another in the estuary and actually spreading these nutrients out. So what we did there, thank you. So what that does is essentially they play a vital role in these ecosystems. So they're a very small animal and something that often gets overlooked because they're so common. So that's a vital thing that we've now found out, that they are actually taking up these plastics, and there is the potential for bioaccumulation, which brings me on to the last point, is they make up a food source for a number of animals. One of them is spotted grunter, so Pomedaceae commersoni. And these are now being earmarked by a farm up in Intanzini called Zini Farms as an animal which is a potential breeder. So they're busy doing research and development on it at the moment as a food source. So I haven't actually been in contact with Zini Farms. I just found it through their website that they are doing research on this grunter. And there's potential, if this species could be bred in captivity, because they do readily produce eggs in captivity. But I don't know if anyone's actually ever tried to follow up through the whole life stage. I haven't found anything on it. But if they could be used as a source of enrichment in aquaculture. But if that is the case, we want to ensure that they're not taking up plastics before they're getting fed to animals, which are then going to be fed to the public. So big implications, and also, they play a vital role in these ecosystems. So there were some limitations to these studies. So for ethical reasons, we used very low replicates. And then fibre counting. This was my most populated filter. It's not the whole filter, it's just a section of it. And you can see there's very extreme overlap of the fibres there. So what we found is that even if we'd used the computer program, the computer wouldn't be able to differentiate between the fibres. So I manually had to sit and count all of these, and that was, we determined, to be the best method. So in conclusion, microplastics are ingested by the species. There is a significant difference in uptake in what's found in their natural range, and there are a number of potential implications for other organisms. Thank you for your time.